All right. So for this lab, okay, we're trying to determine essentially how efficient the conversion of one form of mechanical energy, that would be potential, is into another, okay, and we're converting it into kinetic. So your problem needs to say something about that, okay? We're trying to determine the efficiency of mechanical energy conversion, okay? Something like that. That's what we're investigating here, is efficiency of mechanical energy conversions, okay? How would you be able to calculate that, or something along those lines? Remember, it's got to be in the form of a question. Now, for the design part of this, okay, our end result is that we want to know the kinetic energy of the cart at the bottom of the ramp. Okay, so that's certainly one thing that's changing throughout the lab. Remember, we have a certain name for variables that change as a result of what we do, okay, during a lab. Are there a few things that are also changing in order for us to get the kinetic energy of the cart at the bottom of the ramp? Okay, like when that cart goes off the ramp, what are the things we're measuring? Distance, time, okay? Anything that we measure, okay, that happens as a result of the experiment is a responding variable, okay? So obviously the final kinetic energy is the main responding variable, okay? But there are other things that we're measuring that are also responding to what we do in this lab. Okay, now I want you to think now in terms of manipulated variable. None of those things that we just talked about would change if we didn't do what at the beginning of this lab? Well, not even so much release it. I mean, if I don't put it on the ramp, I just set it on the floor, nothing will happen. Okay, this whole thing. Remember, we're trying to determine the efficiency of one form of energy converted to another form of energy. That means we have to have some to start with. Okay, so we're manipulating something. Okay, at the beginning of this lab, we're doing something. Okay, I'll accept kind of either one. Okay, either it's what we have at the start of the lab or what we do in order to have that at the start of the lab, okay, would be your manipulated variable. That's, I know that seems really cryptic, but I'm pretty sure you guys can figure that out. Okay. Now, in terms of controlled variables, okay, something that we're not, one of the most important controlled variables in this lab is not something we're actively controlling, but it's also at the same time something that's not going to change, hopefully, throughout the lab. Okay, it's something we're depending on in order for the cart to move from the top of the ramp to the bottom of the ramp. Okay, that can't change. If that changes during the lab, not only will the lab be a total mess, but so will the whole world. So we definitely don't want it to change during the experiment or at any other time. Yes, as long as it doesn't change, it's a controlled variable. It doesn't have to be actively controlled. Like when we were doing the properties of compounds lab, temperature was a controlled variable. We weren't actively making sure, but it didn't change either. Right? Okay, remember that you need 3 controlled variables. And for each variable, there needs to be an explanation as to why and how it's being controlled. Okay? So the why part is, what effect would it have on the experiment, right? If you didn't control it, or if it did change, what effect would it have? So you need 2 more. Okay, you can look at the setup here. Anything about this setup that's not going to change during the lab can be counted as a controlled variable, right? We're going to set this ramp up, and that's it. We're not going to change anything about this ramp, okay, once it's set up. We're going to do 4 trials, but it's all going to be the same setup. Okay, I'm not adding more books. I'm not taking books away. Okay, that ramp will be the same all 4 times. You will use the same car each time too. We got to make sure that, okay, all the things that could affect the conversion of energy from top to bottom, okay, are kept the same. Hunter, question? Yeah, it's just going to drop a little tiny bit. It's still a tiny bit, but it's nothing too major. But you could consider that for the end part of this lab report, you know, where you have to list those things that maybe don't work quite right. Okay? So you can maybe write that as in anticipation of doing the lab. It's never good to do your sources of error before you do the lab. You always want to watch what happens in the lab to get a more accurate feeling for that. Okay, for your hypothesis. Okay, the if part of your hypothesis needs to talk about what happens when energy is converted from one form to another. Okay, so if this happens when energy is converted, okay, you can decide how you want to word that, but you need to talk about what happens in energy conversion. Okay? And you can look at this from two perspectives. You can look at it from the perfect physical world perspective or the real world perspective. It doesn't matter to me. Okay, I'll look at either one. Okay? It'll just change what happens in your conclusion. Okay, the and part, as always, needs to describe our experiment. So a cart is allowed to travel from the top of the ramp to the bottom of the ramp, you know, converting this to this. Okay, the then part needs to predict your results. Okay, you need to tell me how the kinetic energy and the potential energy are going to relate to each other in this lab. All right, now in this lab, there's an initiating and planning section. It's not something you need to worry about, like putting on yours or whatever, because I think I already put it in your template. Okay, but it does have some of the formulas that you're going to use, and it tells you what things you need to record during the lab. Okay, because you're going to have to fill in that chart. Okay, that's in there. Okay, for each trial, so the time, the distance, and all that kind of stuff. Okay, and then there'll be some calculations that you'll have to perform with the data that's in the chart. That's all explained in here. All right, so keep in mind there's several variables you'll need to record. Okay, in order to get the potential energy, you'll need the mass of the cart, which I actually gave you up here in the materials. Okay, the initial height of the ramp, that you'll have to measure because everybody's will be slightly different, but they should be around 15 centimeters. Okay? And do you want that to stay in centimeters or do you want that to be in meters? You want it in meters for your calculations. Okay. For the kinetic energy, we'll need the mass of the cart, which again, you already have. The distance traveled by the cart after it leaves the ramp, so that'll have to be measured. Okay. And the final velocity, 0. Okay, we know that. We don't have to measure it. And the time of travel. So someone will have to time it from the bottom of the ramp until it stops. Okay, values you'll need to calculate, acceleration of the cart. Okay, so you'll use this formula right here to calculate the acceleration of the cart. You'll multiply the distance it traveled by 2, and then you'll divide by the time you recorded squared. Okay, it's a pretty easy formula to use, just need to plug it in. All right, then you will calculate the kinetic energy, and you'll do that by setting the work done by friction to stop the cart equal to the kinetic energy of the cart. That'll just be mass times acceleration, which is force, times distance. Okay, that'll give us the kinetic energy at the bottom of the ramp. We'll compare that to the potential energy, okay, which is m times g times h. Okay, simple calculation there, and then we'll be able to compare those numbers. All right, as we said, we're going to do 4 trials, just in case there's, a trial that goes wonky or whatever. At least by averaging the trials, we help to diminish the effect of experimental error. All right, for our analysis, part of the analysis is just calculating things. So calculating the work done or the potential energy, calculating the acceleration of the cart, calculating the kinetic energy. 4 and 5, okay, are the ones that require some explanation. We've already talked about 4, okay? We've talked about how, friction and kinetic energy, so you just need to explain that, okay? And then in number 5, you need to talk about if they're equal, why they're not, okay, or why they are, or whatever it happens to be for your results. Talk about the efficiency, talk about where energy might have gone based on your observations. So your observations are going to be, yes, the measured things, distance and time and height and stuff like that, but your observations also need to include a lot of sensory stuff. So it might not be a bad idea to have one person in your group videoing the lab. Okay, so that you can go back over that video and go, oh, okay, so that was going on. What did I hear during the lab? What does that tell me about energy and things like that during the lab? So it's never a bad idea to get a recording of it, okay, as well. Okay, so I expect that the answers for 4 and 5 are going to be fairly in-depth, which is why it says be detailed here for number 4. Okay, there's several questions actually in number 5, so make sure that you're doing a lot of explaining for both of those answers, yes or no, or potential or sound or something like that's not going to be like a sufficient answer. Okay, then same as always for your conclusion, okay, restate your hypothesis, explain why you accept or reject it. Okay, evaluations, your sources of error, right? You need 2 of those and ways to fix them, same as always. All right, so tomorrow we'll come in here and right away we'll get started on setting up the lab, getting our data, and then hopefully we'll have pretty much the whole thing done before the end of class report included. Okay. All right, so you still got a couple minutes if you're still typing, but pretty quickly we'll need to get those Chromebooks back in the cart.